In some problems, you might be asked to find the angular and linear speed, but sometimes it might require you to change some units that you're working with. So let's look at this example of a radial saw. A radial saw has a blade with a 6-inch radius. Suppose that the blade spins at 1,000 RPM, so rotations per minute or revolutions per minute. Find the angular speed of the blade in radians per minute. So for part A, we're going to start with our angular speed. And we know that angular speed is equivalent to the number of radians covered over time. So if we're talking about 1,000 RPM, we'll think about one rotation of that radial saw. One rotation or revolution covers 2 pi radians. So if we have 1,000 of those, we need to take 2 pi and multiply it by 1,000. So the angle that we have in the top is actually going to be 2,000 pi radians over, and remember this is per minute. So our time is 1 minute. So we can just think of that, you can keep it like this, or if you'd rather, you could say this is 2,000 pi radians per minute. So this would be our angular speed, and our units worked out. They looked for radians per minute, and that's what we have. For part B, we're looking for the linear speed. But notice that this is asking for the linear speed of the saw teeth in feet per second. Well, my radius of the radial saw is given in 6 inches. So right now we're in inches and then per minute for time, and we want feet per second. I'm not going to worry about the feet per second yet. Let's just go ahead and work with what was given to us, and then we'll adjust at the end. So as a reminder, your linear speed, you just take your radius and you can multiply that by the angular speed, because your angular speed is theta over time, right? Linear speed is r theta divided by t. So our radius was 6 inches. We need to multiply that by our angular speed, which was 2,000 pi. And what we would get here is 12,000 pi. But remember, our units are going to be in now inches for that arc length per 1 minute. So inches per minute, that's not really what we're looking for. So if we want feet per second, this is where we're going to use our dimensional analysis. So we can take what we have, which was 12,000 pi inches, per 1 minute. And now we need to multiply by a unit rate to help me to convert inches into feet and then minutes into seconds. So let's talk about inches and feet. I know that there are 12 inches in 1 foot. So I could either multiply by 12 inches over 1 foot or 1 foot over 12 inches. And I'm going to choose to do 1 foot over 12 inches. And the reason that I'm doing that is we had inches in the numerator here. So if we have inches in the denominator, they're going to simplify, and now we would have feet per minute. Then I'm going to multiply by another unit rate because we have the feet. Now we need to get minutes into seconds. So I know that there are 60 seconds in 1 minute. So I can either multiply by 60 seconds over 1 minute or 1 minute over 60 seconds. And for us, we're going to want to multiply by 1 minute over 60 seconds because the minutes are in the denominator here and the numerator here. So now I can see that I'm left with feet per second. So my numerator is in feet, my denominator is in seconds. So now we just multiply across. So 12,000 pi times 1, that's still 12,000 pi. And then we have 12 times 60. So if we're going to multiply, let's see, 12 times 60, if I get my calculator out, that's going to be 720. So now I want to simplify this for my linear speed. So we can use our calculator and we can either simplify 12,000 over 720 if we wanted an exact answer, which would actually simplify to 50 pi over 3. And this would be feet per second. Or to approximate it, if we type that in our calculator, this is going to be about 52.36 feet per second, which probably makes more sense to us. We can envision what that looks like, covering about 52 feet every second.